Hey guys, Mr. Aguilar here. Sorry, I'm writing up a lesson for you guys. I want to make sure you guys are understanding for our 5.2 trig ratios and analysis. Because I'm not here today, I want to give you guys an opportunity just to kind of catch up and to copy down some notes for me for today. Giving you a couple of things, you guys can always pause it, stop it, go back. These notes will be due, so make sure that you guys are taking the time and actually trying these problems out. It's important that you guys have your unit circle here. The substitute will have extra, but you should be able to have that out. This is going to be the key thing that you're going to need to show for some of these types of problems. Again, copy down everything you see or everything that's missing on your page. We did some problems like this yesterday. Number one is the point P is on the unit circle, point Y is if it exists in the coordinate plane for 2. So we want to be able to try to apply these. I'm looking at the first one. You guys saw this yesterday as, change the color, P to the X is equal to, or not X is equal to, but our coordinate plane here, and existing in quadrant 2. So because we know the quadrant 2 is this location, we know that the point should be both negative and positive for the y. So we're looking, when we solve and taking the square root, we should get a positive x value, or negative x value. Using the equation, x squared plus y squared is equal to 1. We're going to plug in our points, x squared plus 2 rad 6 over 7 squared is equal to 1. You guys can definitely do this in your calculators, but x squared will be equal to, we're going to subtract 1 from 1 squared. I calculate it right here. Okay, you guys can definitely skip forward if you guys need to. So 1 minus 2 rad 6 over 2 rad 6 over 7 squared. Okay. When you simplify this out, you're going to get 25 over 49. Taking the square root, we're going to get x is equal to plus or minus 5 rads, or 5 over 7. But because we're looking in quadrant 2 right here, we know that the x value must be negative. So negative 5 over 7 is our first one. So very typical problem you might see on the final or our half test. The bottom ones are fairly simple. We should be able to identify where the terminal points is on our unit circle. In this case, looking at where 5 pi over 3 is, it's in quadrant 4. So to give you a quick diagram for this, our quick diagram is in quadrant 4 here, and it gives me the coordinate point 1/2, or the terminal point, rad 3 over 2. So what I want to be able to see with you guys is its location and what the terminal point would be for your value. Okay. Other one for B, again, given the graph of this, our terminal point is 5 pi over 4. 5 pi over 4 is our regular 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this is in the positive direction, so I'm going to count that backwards, which will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is our terminal point at this location. It falls at 3 pi over 4. The terminal point for this will be rad 2 or rad 2, rad 2. Okay, these are what I'm looking for these. Sorry, these are not the best. These are not the best notes, but again, you can always pause it and continue. Really try to practice this stuff as we kind of go along. The next part that we're going to look at is the actual note. So this is 5.2 trigonometric functions of real numbers. The objective is to evaluate trig functions given our terminal point t. And you guys found this using your ratios yesterday. So just looking at those notes from yesterday, it should be fairly easy for us to do. But again, we'll practice this on Friday and review everything we've done so far, and then get into graphing. So again, to kind of fast forward for this, we have our unit circle here. So if you need to take a picture of your screen, if you don't have an extra one, you can always do that there. And then we're going to kind of get into it. So understanding sine, cosine, and tangent in relation to the unit circle is also important. Given our terminal point, we can look about going around the circle, which gives us a point x and y. We look at t, whether it's pi over 2. This example here on our screen looks like it's 2 pi over 3, and it would give us a coordinate point of -1/2 radical 3 over 2. So we want to be able to use these. These are the key identities that we want to be able to use. In our terminal points, P, or the point that's given on the unit circle, we can associate different values for these. Specifically, the ones we're going to kind of focus up on is sine, cosine, and tangent. Secant, cosecant, and cotangent are the inverses of these functions, but we are going to generally look at these functions. So in the examples here, I know it tells us to look at all 6 different functions, but we're going to go ahead and just look at the 3 of them because that's the one we're going to focus on. So technically, if I had to, I'm going to kind of eliminate these here. We're not going to really need to look at these for the time being. It's important that we just look at the functions themselves, sine, cosine, and tangent, for our terminal points. So given the terminal point at specific values on the unit circle, we're going to be able to identify these. So it's better just to jump into functions themselves, okay? So it tells us to ask for the 6 trigonometric identities given the function. So in the example yesterday, and we're just going to do 3 of them, so let's change that to 3. Find the 3 functions of the given real t. So you guys did this yesterday. Given the terminal point or the terminal value, find it where it's pi over 3. And the way we want to be able to identify this is just go ahead and find me the terminal point. So I've given you guys a unit circle, and find out where this value is going to be at. The first one being at pi over 3. So looking at my unit circle here right next to me, drawing this here, this is where our unit circle is going to lie, right? You should be able to tell me the terminal point that exists. In this case, the terminal point for this value of t is going to be at 1/2 rad 3 over 2, okay? And the way that we want to be able to identify these are specifically, we have several things where sine of our terminal point is the y value, cosine of the terminal point is the x value, and looking at tangent of the terminal point t is y over x, right? So let me kind of make sure this is looking back what we just did. This is kind of going back to the functions here, okay? Our functions are identified as sine of t of y, cosine of t of x, and tangent of y. So what we want to be able to understand is that our point P is just x, y. So in relation to each one of these points, we can identify where they exist in our line. So the answers for these would be where sine of pi over 3 is simply the y value, in this case rad 3 over 2. For cosine, it's the x value, so cosine of pi over 3 is equal to 1/2. And what we're getting for the last one is the ratio of y over x. So tangent of pi over 3 is simply going to give us radical 3 over 2 over the tangent, the x variable, okay? In this case, if you plug this into your calculator, you should get radical 3. So our solutions for these is looking at the trig ratios in relation to the given t value. So these are what it's going to look like. These are the 3 trig functions for each given real number of t. So these are what we're going to look at for these next couple ones. So just being able to identify those is kind of important. Okay? So again, pause it, look over it. We're going to do a couple of these, and then we're going to kind of look at more trickier types of problems. This shouldn't be hard for us. Again, you should be able to identify that on your unit circle at pi over 3, we're given the coordinate points 1/2 rad 3 over 2. And that's the point we're using for this given t real value where it exists. So for the next one, let's look at this next one down here. Okay, it's giving you the ratios for these. So we can even apply these to the negative values. So 5 pi over 6 is where our t is going to exist. The real 5 pi over 6, the 5 pi over 6, is this location right here. And there were some questions yesterday on how do I get these values. And let's see, is it not working for me? So let's try this again. Okay, that's the 5 pi over 6. In this case, in order for me to go in the positive direction, I would count 1, 2, 3, 4, 5, 6, 7 just to get to this. Just to get to this point. But because we're going negative, our t is negative, we got to take that backwards. So we're going to go backwards on starting at our initial point. We're going to go back 1, 2, 3, 4, 5, 6, 7. So this point right here, in graphing this, is when t is equal to negative 5 pi over 6. Okay? Can you tell me this coordinate point that exists? So no, yesterday you guys were giving me this. You guys should be able to give me that point that it represents. Looking at my unit circle again, you guys should have this in front of you. We're going to be given the coordinate point. Okay, we're going to be given the point on the unit circle, negative rad 3 over 2, comma, negative 1/2. This is the point in which is at negative 5 pi over 6. So now it's asking us for the 6 trig ratios again. We've known to not do this, so let me kind of change this again. It's a little bit darker. We're going to look at just 3 main key identities for our trig. So again, we're looking for when sine is negative 5 pi over 6. We're going to look for cosine of t, in this case, negative 5 pi over 6. And we're going to look for tangent at negative 5 pi over 6. And you guys have the ratios right up above you. These are what we're going to use to identify our functions, excuse me. Sine in this case, we just have p, this is x and y. We know that sine is associated with the y value, so we can assume it to be just negative 1/2. This is our first one. Okay. Next one that we're going to look at is cosine. Cosine is dealing with the x variable. So the x variable in this case is negative rad 3 over 2. And our last one here is going to be the ratio of y over x. So we're looking at y, negative 1/2, over the ratio negative rad 3 over 2. Okay. Again, plugging this into your calculator, you should be able to be simplifying. We're getting both negative versions of these, so negative times a negative is going to make this positive. And doing this, so I'll show you guys how to plug. So if you guys plug this in directly, we should get 1/2. Let me make sure that this is going to work for you guys. Rad 3 over 2. If you simplify this down, you're going to get radical 3 over 3. This is our solutions for each one of our types of functions here. Okay, so we're really looking for our solutions of this one, and this one for the function values. That is what we're looking for our solutions for these. So really simple, really easy, being able to identify these key, and I'll probably give you guys one for your do now tomorrow, just so you guys can check one out and see if you guys can provide me these. Hopefully you guys remember how to do these. So again, pause it, review it, look it back, and then we're going to continue on going. There are some problems at the end of this that are good to go over, but I'm not going to be too focused on. These are now asking you in reverse. So you're given the terminal points for these. Can you just provide me the direct number for this? So I'm going to change C into just something more simpler, more simple for us. Let's do this, negative 3 pi over 2 for these values. So again, because we're now looking at the terminal value, 2 pi over 3, okay, this is in the positive direction. This is the t value. This is the t value. So looking at the unit circle, where does 2 pi over 3 exist? What coordinate point does that give me? In this case, 2 pi over 3 is in quadrant number 2 at negative 1/2 rad 3 over 2. We're asking for the cosine of that terminal point, that terminal real number, that given number t. So in this case, we're looking at cosine of 2 pi over 3 is simply going to be just the x variable, the x number here, so negative 1/2. So this is going to be our solution for this. Okay, so that's all you're really doing. You're identifying where it is on the unit circle. Again, for those that need help or visual seeing this, unit circles here, 2/3, this is where t is equal to 2/3, 2 pi over 3 is here, and we're given this coordinate point that it represents. So we're going to continue. For the next one, we're looking for B. Again, I'll try to draw this out. Where does negative pi over 3 exist on the unit circle? Well, positive pi over 3 is right here, so I'm going to go backwards 3, and it's going to be this coordinate point down here. The coordinate point associated with this is at 5 pi over 3, so we're going to give in 1/2 negative rad 3 over 2 is the associated point for negative pi over 3. We're asked for tangent, so tangent is going to be the ratio of these two numbers. So tangent of negative pi over 3 is simply going to give us our y variable, so negative rad over 3, okay, divided by the x variable, or over 2. Again, plugging these into your calculator, multiplied by its reciprocal, we should get negative rad 3 for your solution. And again, just checking, you can make these ratios correct, and you can make these in your calculator, and the calculator will punch out rad 3 over 2 to 1/2. Okay. Just to make sure we're right, it does give me the correct negative rad 3, again, because we have that negative value up in front. The last value here is sine. So we're going to look at when sine is at negative pi over 3. Again, I'll try to draw a little picture down below. In this case, hopefully it's not getting in your way. Pi over 3 is at the top of this part right here. Sorry, it's at the bottom. So we're going to count. I can just count the longer x-axis. This is 1, 2, 3. So I'm going to count this in reverse. So the terminal for t for this would be here. This would be at 0, 1. Again, simply sine of negative 3 pi over 2 is the y variable, the y number here. This is just a point. So we're looking at here, and it's just going to give us 1. So these are what we're looking for the function values for these. So very straightforward for these type. And that's all I'm going to really be asking you for these type. Again, you guys have the unit circle for you, and apply them, and that's it. So we've looked at terminal points, how cosine is associated with x, sine is associated with y, and tangent is the ratio of y over x using these points. So we can actually look further, and again, I would try these ones out. You guys can do these later. But let's keep on going with this. Okay. So the next thing I want to be able to understand and look at is, again, we're not going to look at these negative functions. You don't need to worry about these negative functions, but just being able to identify these key parts to them. We should be able to associate the types of functions we're looking at. Looking at the unit circle, we have this acronym ASTC, stands for all The acronym always comes from all, quadrant 1 is all students take calculus, okay? And the reason why we want to be able to use that is whenever you're given a solution like last, where it asks you for a cosine of negative pi over 3, you can look at the unit circle and identify. You should be able to tell me the values or the signs of them, meaning that in our point here, x is going to be positive, y will be positive as well. So these are both cosine is positive, sine is positive. For the next one, we're going to have a negative and positive, meaning that only thing that's going to be in this quadrant that it will be positive will be the sine value. Tangent will be the next one because we have a ratio of y over x, y is a negative, x is a negative, making it positive. And then for the last one, positive negative, which is our cosine value. And I'll show you how this is associated. If you just want to look at your unit circle, you can definitely identify these. But sine functions, or looking at how to identify these functions and whether they're positive or negative, is associated with this all students take calculus. Or if you write out the coordinate points, you can identify, okay, this is going to be my cosine, this is going to be sine. So both of them are going to be positive, therefore tangent, which is a ratio between them, will be positive. Okay, so the next one will be cosine and sine. Okay, well, this is going to be the only thing that will be positive in this function is only sine. Tangent, cosine will both be negative. And then again, cosine, sine, the ratio between them is going to be positive, and then cosine and sine. So maybe I'm confusing you more than what you need to, but just understand that you guys have these function values. The lights just turned out on me. Let me go and turn it back on really quick. Sorry about that. So let's look at a problem, what I can ask you guys. So talking about these ones, these are the types of things I'm going to ask you. So just determine the signs of them for the following trig. I'm not going to ask you what the coordinate point is for these. So whenever I associate, determine the signs for the following trig functions. So is cosine of pi over 3 positive or negative? It depends on the location of the point. So looking at where pi over 3 is, we want to be able to identify this location of pi over 3. You guys have the unit circle in front of you, so you guys know it to be in this quadrant. This is in quadrant 1. And in quadrant 1, all signs are positive. So in this case, cosine of pi over 3 is simply going to be a positive solution. Specifically, we know what cosine of pi over 3 is. Looking at the x variable, the cosine of it is going to be 1/2. That's the value. So we're just looking at whether it's positive or negative. I'm only looking for these answers, but again, we can associate whether they're positive or negative depending on the location they exist. Looking at the next one, we're now asking where sine, okay, of 7 pi over 4. So sine is associated with the y variable. Where is 7 pi over 4? Well, you look at your unit circle. 7 pi over 4. In this case, it's in this quadrant. We're looking at quadrant 3. All students take calculus, okay? The only thing that I know to be positive in here is going to be my cosine. So that means sine must be negative. So this is positive, this is negative. So looking at the associated value, I know sine will be negative. It will be negative. Specifically, it will be negative rad 2 over 2. And specifically, if you look at that on the location point, or you look at the point that we're given here, this is the sine of 7 pi over 4 is negative rad 2 over 2. So I'm only asking you for where the signs exist for these. So look at them and try to observe them. The next one that we're going to try to do, okay, is a combination between the two. So we want to be able to identify find the sign of the expression. So is this positive? Is it negative? And that's all we're trying to get at. In quadrant 2, so let's look at the values in quadrant 2. Anything that's associated in quadrant 2, we're going to have both x is going to be y is here, and we know that to be the points here are going to be both negative and positive. So sine, which is associated with the y variable, right? This is associated with the y variable, is going to be a positive number. Tangent is going to be a ratio between that. In this case, y over x, right? So let me kind of write this up a little bit. This is going to be y over x. What's y? Y is positive over a negative function. So this is definitely going to make it negative. So negative times a positive is going to be negative. The sine of sine t tangent t is going to be negative. And so that's what we're looking for. So we want to be able to associate these function values that are representative here. Okay. So next part that we're going to do is the bottom one. So it's asking us that the t lives in quadrant 4. Quadrant 4 is at the bottom down here. This is Q4. It doesn't matter where this exists. We're just looking for what sign it will be. Will sine squared t cosine t be positive or negative? And we can associate that given the property. In this case, we know we have a coordinate point x and y. We know that in this quadrant, it will be positive negative, right? All students take calculus. The only thing that will be positive is the x term. So let's look at our y variable. In this case, sine is negative in quadrant 4, which is squared. So a negative times a negative will make it positive. And then cosine in this, which is dealing with our x, will be positive. So a positive times a positive will remain positive. So the numbers associated with this, we're saying this is going to be positive for sine squared cosine t. Okay. Okay. And again, I'll try to make sense of this more tomorrow if it's confusing you, but all I'm asking you is find the sign. Sign means whether it's positive or negative. So in this case, I'm going to clear this. We know what our associated value, so sine, our answer, if you want to clear a nice solution, is going to be negative, right? The solution for us is going to be negative. And we know that the bottom one, cosine t, is going to be positive. So that's all I'm asking you guys to do. Okay. Very simple, very straightforward. And I can give you some problems to try out. Okay, this is the practice that I want to see you guys do. This is the classwork, I guess. So determine the functions, the function values for here. Okay, don't do cosecant. Don't do cosecant. So we'll just do tangent for the following. Okay, find the value. Use your unit circle. Where 5 pi over 6 is, it's in quadrant 2. Tell me the point, and then tell me what tangent is y over x term. Okay. I'll let you guys finish that one up. Okay. And also, the last ones, okay? This is what basically I'm asking you guys to do today. What is tangent of t squared? So if it's positive or negative, what quadrant does it exist in? Don't do the bottom one. Again, just do A for me. And this is what I'll be checking for tomorrow. Yeah, I'm looking for you guys to practice these. It will be on the bottom of your note pages, so I will not be doing these, but these are what I'm going to be looking for tomorrow. So the 2 base screens you guys are looking at is what I'm going to be grading for you guys. Okay, and we'll kind of recap everything. Don't worry about these. Let me see what else we got. And these are just good practice problems for you guys to check out. If you really need to do some problems, exact number of the trigonometric identity, cosine. So these are good ones to do. It gives you the point already. So 25, 26, these tells you where, right, find sine, cosine, and tangent. This is x and y. And then try this one and this one. These are the 2 that are really good to look at, okay? Other one is find the trigonometric ratios of these ones. And this one are good as well. Don't do 3, don't do 5, 45, 46, okay? We'll talk about those on Friday if I need to, okay? Besides that, you guys are good to go. I hope this wasn't too long. Have a good day, guys.